So, a deadly disease affects 1 in 1,000 people. Fortunately, there's a test for the disease which is 95% accurate. 95% of those who have the disease test positive, and the other 5 test negative. And 95% of those who don't have the disease test negative, and the other 5% of those test positive. If you are randomly given the test for the disease and test positive, how likely is it that you actually have the disease? So it sounds pretty scary, since the test is 95% accurate and you just tested positive, but it turns out that it's not as bad as you think. What the question is asking is, if you tested everybody, what percentage of those who test positive would actually have the disease? And it turns out to be pretty low, because there's so many more people without the disease that even a small false positive rate gives you a lot of people who test positive without having the disease. Let's see how that works. The key is to make a tree diagram and just pretend that we test 100,000 people. So here's 100,000 people who are all being tested. Now, the disease actually affects 1 in 1,000. So in those 1,000 people, 100 of them are actually sick. So we'll indicate that here. It's 100 who are actually sick. And the other 99,900 are okay. They're healthy. Okay, fine. Now, of the sick people, 95% of them are tested for the disease, and 95% of those test positive. So 95% of 100 is 95. So here's 95 people testing positive. Let's put a positive sign there. They tested positive. And the other 5 people, they have the disease, but they tested negative. Now, how about the 99,900? Well, how many of those test positive? Here it's only 5%, because they're actually healthy, and so the disease accurately tells most of them that they don't have the disease. Only 5% of the 99,900 test positive, but 5% of a big number is pretty big. 5% of 99,900 is 4,995 who test positive. And the rest, not that we really care, 94,905 test negative. So who tested positive for the disease? These 95 and these 4,995. So total testing positive, we add the two together, 95 plus 4995 equals 5,090 tested positive. Of those who are sick, actually sick, well, only the 95. So total positive, 5,090. Total of those, 5,090, those who are actually sick, is 95. So if you test positive, what percentage of the people who test positive actually have the disease? 95 out of 5,090, which is about 0.019, or less than 2%. Test positive, less than 2% are sick. At first, this is somewhat surprising, but when you think that it's a very rare disease, it's really not that surprising. It's a rare disease, and so the small percentage of healthy people who test positive totally outweighs the large percentage of sick people who test positive. So this is how a tree diagram, and just starting with a hypothetical 100,000 people, can help us solve pretty hard problems.